All right, you are welcome again. Okay, I trust you are doing well. Now, let's take a look at this problem under differential equation. Okay, under differential equation, it says solve the differential equation y prime is equal to xy plus x plus y plus 1. Okay, so this is a differential equation, ordinary differential equation, and we are asked to solve this. Okay, how can we go about it? Now let's go. Now this y prime is the same as saying dy dx. Now we say is equal to xy plus x plus y plus 1. Are we together? Good. Now pay attention to this equation. How can we approach this? So now let's try to group the right hand side. Let's try to group. Okay, so grouping, we are going to have it like this: dy dx is equal to, this is four terms. We are going to group it 2 by 2. So here we have x plus y. Sorry, here we're going to have xy plus x in bracket plus then y plus 1 in bracket. I think it's okay like this, right? So if you remove this bracket, you still have your common terms. Are we together? Now, these terms that we just grouped now, let's see if we have anything in common in both brackets to factorize. Okay, now let's look at it. In this first bracket, where we have xy plus x, what do we have in common here? We can see x there, right? Let's factor out x. So factoring out x, we are going to have x open bracket y plus 1. That is when you factor out x from xy, y will remain. Okay, when you factor out x, 1 will remain, right? Good. So here we have dy dx is equal to x open bracket y plus 1 plus. Now the other side, what do we have in common there? You can see that we don't have anything in common, but just a common factor of everything is 1. So let's factor out the 1. So when we factor out 1, we have 1 open bracket y plus 1. So here we can see that we have two brackets and the content of these brackets are same. Okay, so we pick the terms outside the bracket and pick one of the brackets. So that is factorization. Are we together? Now let's go. So here we have dy dx is equal to x plus 1, that is the x and the 1 outside, then multiply by y plus 1, which is one of the content of the brackets. Okay, so this is the factor of the above right hand expression that we have. Okay, so here we have that dy dx is equal to x plus 1 in bracket y plus 1 in bracket. So I want you to do me a favor. Try to open this bracket. Okay, try to open this bracket and see if you are going to get the same thing. I'm very sure it is correct. Are we together? Now let's go. What do we do next? From here, we can try to separate the variables. Okay, because when you look at this carefully, you can see that you can use separation of variable to solve this. But first, let's multiply by dx. Okay, this dy dx, let's split it so that dy will be in one side, dx will be in one side. So multiply by dx. So when we multiply by dx, we're going to have dy is equal to x plus 1 in bracket, y plus 1 in bracket, dx. You understand, right? Good. Now let's go. So from here, we can apply the method of variable separable. So that is separation of variables. So everything pertains to x, and the x will be in one side, y and dy will be in one side. Okay, so how can we do it here? You see that by our right hand side we have dx there, so we are going to maintain dx and everything x in our right hand side. So you see that in this our right hand side, y is mixed. So y plus 1 is mixed, so it's not needed there. So we are going to divide the right hand side by what? Y plus 1. So meaning if we divide it by y plus 1, the y is going to be eliminated from our right hand side. So whatsoever that will remain there will just be x and the x, right? So now let's do it to the left hand side also. So that means we are dividing both sides by y plus 1 so that we will separate the variables. Now, when we do that, we are going to have that dy all over y plus 1 is equal to x plus 1 dx. Yes, I think we are together, right? Good. Now let's go. You see here clearly that the variables has been separated. Okay, x and the x is by one side, y and the y is on the other side. Okay, so what do we do next? We integrate both sides. So integrating both sides, we are going to have the integral of dy all over y plus 1 is equal to integral of x plus 1 dx. Are we together? Yes. Now let's go. So this left hand side is the same thing as saying the integral of 1 all over y plus 1 dy is equal to the other side integral of x plus 1 dx. Now let's integrate proper. When we integrate 1 all over y plus 1 with respect to y, when we integrate 1 all over y plus 1 with respect to y, is going to give us ln y plus 1 equal to, when we integrate x plus 1 with respect to x, is going to give us x squared all over 2 plus x, then plus c, our constant, right? Good. So here we have ln y plus 1 in bracket is equal to x squared all over 2 plus x plus c. So what do we do here now? We take the exponent of both sides, or we simply say we exponentiate. Okay, so that is to say we are going to say e raised to the power of ln y plus 1. Okay, so this e raised to the power of ln, we are taking the exponent, right? So it's going to cancel. We are going to have y plus 1 remaining there. Now equal to the other side, we have e raised to the power of x squared all over 2 plus x plus c. Are we together? Yes. Now let's go. So here now, look at this right hand side where we have e raised to the power of x squared all over 2 plus x plus c. Now let's apply the law of indices. The law of indices, we are going to bring out e raised to the power of c. That means going to give us e multiplied by e raised to the power of c. Now look at this. Look at this. We are going to have y plus 1 is equal to e raised to the power of x squared all over 2 plus x times e raised to the power of c. So when you apply the law of indices, it's the same as what we have the previous, right? Good. So here now we're going to say that let this e raised to the power of c, let's call it a letter c1. So when we call it a letter c1, we are going to have y plus 1 is equal to c1 multiplied by e raised to the power of x squared all over 2 plus x. Are we together? Let's take 1 to the other side. Taking 1 to the other side, we have y is equal to c1 e raised to the power of x squared all over 2 plus x minus 1. Are we together? Yes. So this is the solution to the ordinary differential equation y prime is equal to xy plus x plus y plus 1. Hello. All right, let's take another problem on the differential equation. Thank you very much for watching. Please, if you are new to our YouTube channel, do us a favor, like and share our videos. Stay blessed. Thank you.